Hi, in this video we are going to see about a Python IEEE project which is entitled as Fruit Quality Detection using Deep Learning for Rotten and Fresh Fruits Classification, which is an enhancement of IEEE base paper titled Fresh or Rotten, Enhancing Rotten Fruit Detection with Deep Learning and Gaussian Filtering, which is an IEEE 2025 journal paper. So before seeing the execution of the project, let me brief about this project. So in agriculture and food industry, maintaining the quality is one of the important thing for the customer satisfaction and having a good quality food. So especially in fruit grading system, fruits will be rotten soon or it may be damaged. So to overcome that, fruit grading system is maintained. So in the fruit grading system, the existing, they will be manually checking whether the fruit is damaged, whether it is fresh or rotten kind of thing. But this manual kind of thing is time consuming, and also the payment, the charges made to the labor are very high, so that the farmers or agriculture or the food processing people cannot able to afford that. So due to the advancement in the artificial intelligence nowadays, in this base paper, the authors have introduced the deep learning model for the fruit grading system, so that it will be detecting whether it is a fresh or rotten fruit. So here you can see a pictorial representation that is mentioned in the base paper, where automated fruit quality inspection, whether it is detecting that the fruit is rotten or fresh. It is a pictorial representation. So in this base paper, the authors have used the transfer learning model ResNet 50 convolutional neural network architecture as binary classification. They have used two classifications, that is fresh or rotten. So here the authors have enhanced it with the Gauss filter and dropout layer to ensure the robustness and prevent the overfitting. So here the authors have used the deep learning model for making the fruit detection quality, whether it is a fresh or rotten. So there is two classifications they have used. And coming to the data set, so here you can see the 8 different fruits they have used. So they have used grape, guava, jujube, pomegranate, strawberry, apple, banana and orange. So they have used total 200 images for rotten state and another 200 for the fresh state for each category. So totally they have used 1600 images for rotten fruits and another 1600 for the fresh fruits. So these all the images about the images data set that they have taken. So based on that, they have implemented and they have achieved around 99% of accuracy. So this is about the base paper. Kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system and how we are going to enhance from the base paper concept. So first thing, we are going to implement two different models. So one is Inception v3 architecture and the next model is MobileNet v2 architecture. So in the Inception v3 architecture, we have achieved the training accuracy of 94% and validation accuracy of 94%. And coming to the next model, MobileNet v2 architecture, we have achieved the training accuracy of 97% and validation accuracy of 98%. Now let us see about the proposed system. So the proposed system title is Fruit Quality Detection using Deep Learning for Rotten and Fresh Fruit Classification, and this is the IEEE base paper abstract. And coming to our project proposed abstract, so assessing the fruit quality plays the important role in the agriculture and also for the food sectors to enhance the customer satisfaction, so that the wastage will be minimized. So in this project, we have developed the fruit quality detection using deep learning for rotten and fresh fruit classification, so that it is being classified into 3 different categories: good quality, bad quality and mixed quality. So here we are going to developed the project using Python as the backend, and for the front end we have used HTML, CSS, JavaScript, and for the web framework we have used Flask. So here we are going to use two convolutional neural network models, that is Inception v3 and the MobileNet v2. So now you can know in the base paper they have used only binary classification, that is two things, that is fresh and rotten fruits. But here the proposed system, we are going to enhance the system by adding one more thing, that is good quality, bad quality, and mixed quality. So total we are going to make it 3 classes, and also we are going to add 2 different models from it. So in the traditional method, the fruit grading systems are time consuming and also leading to inconsistency and the human error. So to overcome this, we are going to address and we are going to implement this system to make the system accurate and the scalable solution for the fruit quality detection. So here, coming to the data set part, so here you can see we are going to use 19,526 high quality images. So you can see we have to the total data set images that they have used in the base paper is only around 1600 plus 1600, so around 3200. But here you can see we are going to use 19,526, which is a very large data set, which we are going to use for the 6 different classes: apple, banana, guava, lime, orange, and pomegranate. So which all the fruits that is commonly used, and this is being categorized into 3 different classes or categories like bad quality, good quality, and mixed quality. So in the bad quality we'll be having 6,788 images. In good quality we have 11,664 images, and mixed quality we have 1074 images. So in the each category contains the 6 fruits, and the data is processed and structured into subfolders. So let us, before moving to the next part, I'll just show you the data set images. So in the model part we have this data set. So here you can see the bad quality, good quality, mixed fruits. Now let us see each things one by one. So in the bad quality you can see all the 6 class, that is fruits: apple, banana, guava, lime, orange, and pomegranate. Similarly in good quality you can see the same, and in mixed quality you can see all the apple, banana, guava, lemon, orange, and pomegranate. So let me show you all the things. So now in the apple bad part you can see these all the images that we have used for the apple bad part. So you can see and scroll down and you can see. And now let us see about the banana bad. So you can see this is banana bad images. So you can see that these all the images that is available in the banana bad images. And coming to the next part, that is guava, you can see these all the guava bad images. So these are the guava bad images. Coming to the next part, that is lime. So lime bad images. So these are all the images that is available in the lime bad class. And coming to the next class, that is orange bad. So these are the images that is available in the orange bad, and this is the images that is available in the pomegranate bad. So these are all the images that is available in the pomegranate part. And now coming to the good quality, so you can see the good quality apple here. These are all the good quality apple images. And banana, now let us see about the banana good quality images. And these are the guava good quality images, and this is the lime good quality images. These are the orange good quality images, and these are the pomegranate good quality images. So now coming to the final class, that is the mixed quality. So this is the additional feature that we have implemented here. In the mixed quality we'll be having the mixed of good and mixed of the good and the ripe, that is bad quality mixed with it. So you can see that both the classes in it. Now this is guava mixed and this is lime mixed and this is orange mixed and this is pomegranate mixed. So now in the existing system they are trying only with the one image, that is if it is an apple, that is an banana kind of thing, they are trained with only one single image. But here in our proposed system we are going to train up with the multiple images in it. So each class, that is banana, pomegranate, lime, so each class which contains the multiple images in it also. This is an additional enhancement that we have done other than from the base paper. So coming back to the abstract part, so we have discussed about the data set. Now coming to the pre-processing. So after the data set is being loaded into the system, we'll be making the pre-processing like data frame creation, label type conversion and sample image dimension analysis. So after these, the system is being trained with the our two proposed model, that is one is with the Inception v3, another is the MobileNet v2. So finally we will be evaluating our proposed system using the performance evaluation matrix, like recall, F1 score, precision and the confusion matrix, and we show the results with the chart analysis also. So now let us see about the existing system. So as mentioned, we are going to take the base paper as the existing one. So in the base paper, the authors have used the enhancing rotten fruit detection with deep learning and Gaussian filtering for the critical issue of post-harvest fruit wastage through robust deep learning based solution. So here they have focused on binary classification, whether it is a fresh or rotten, by employing the convolutional neural network architecture enhanced with the Gaussian filtering technique. So here they have, in the existing system, they have used VGG16, ResNet 50 and MobileNet v3 small to achieve the higher accuracy classification conditions among the 8 fruit types, including the grape, guava, jujube, pomegranate, strawberry, apple, banana and orange. So in the existing system they have used the total image dataset, which was around 3200 RGB images. So they have equally divided that between the rotten and the fresh category. So each fruit category contains 200 original images of its rotten state and another 200 with the fresh state. So total they have made 1600 images for the rotten fruits and 1600 for the fresh one. So in the ResNet model they have applied the Gaussian filter and they have achieved the highest performance with 99%. And this model holds the promise for the practical deployment in post-harvest scenario like sorting lines or storage facility, providing a cost-effective automated alternative to manual insection. So these are all the things that is mentioned in the existing system part. And now let us see about the disadvantages of the existing system. So the main disadvantages of existing system is lack of real-world environmental variability and dependence on high resolution image capture, sensitivity to Gaussian filter parameters, binary classification limitation, limited fruit variety handling, control environment dependency, lack of multi-class differentiation capability, no label encoding for detail analysis, limited model benchmarking, lack of visual performance insights, inflexibility in deployment of web interface. So these are all the main disadvantages of the existing system. Now let us see about the proposed system. So in the proposed system, they are designed to automate the classification of the fruit quality using the deep learning technique on the 3 distinct classes: good quality, bad quality and mixed quality. And we have developed using Python, HTML, CSS, JavaScript and Flask for the web framework. So here we have used 6 specific fruit types: apple, banana, guava, lime, orange and pomegranate. So here we have used 2 different convolutional neural network architecture. One is Inception v3 and other one is MobileNet v2. So here we have achieved the training accuracy of 94% and validation accuracy of 94% for the Inception v3 model, and whereas MobileNet v2 outperformed rather than the Inception v3 with a better training accuracy of 97% and validation accuracy of 98%. So the models are trained using the 19,526 high resolution images with the good quality images containing 11,664 images, bad quality with 6,788 images, and mixed quality with 1,074 images on the each classes of the fruits. So before training the model, the dataset images are pre-processed into several steps, and finally the dataset images are trained with both the models, and finally we show the performance analysis with the precision recall F1 score and the confusion matrix, and also we show the performance analysis and the static visualization graph for it. And now let us see about the advantages of the proposed system. So the main advantages of the proposed system are multi-class fruit quality classification, high accuracy with lightweight deep learning models, comprehensive data set and structured pre-processing, robust evaluation and visual analysis tools, user-friendly web interface for real-time prediction, scalability and adaptability, reduced human error and time efficiency, potential for real-world deployment. These are all the main advantages of our proposed system. And now let us see about the system architecture. So now we are going to provide the input fruit images data set. So after that it is pre-processed and feature selection is made, and it is being trained with the Inception v3 architecture separately and MobileNet v2 architecture separately, and the predicted result will be any of these, that is apple bad, apple good, apple mixed, banana bad, banana good, banana mixed, guava bad, guava good, guava mixed, lemon lemon bad, lemon good, orange bad, orange good, orange mixed, pomegranate bad, pomegranate good, or pomegranate mixed. So any of this will be the performance analysis, and finally we show the performance analysis and the graph part of it. And now let us see about the system requirements, and these are all the minimum hardware requirements, and these are the software requirements. The project can be executed in Windows 10 or 11. The coding language we have used is Python 3.12.0. The framework is Flask. Front-end part contains HTML, CSS, the JavaScript. So this is the reference of the IEEE base paper. So now let us see the execution of the project. So just go into the source code location. Inside that we have this fruit quality classification folder. Inside that we have the app.py for other file. So now in the address bar type cmd and click enter. So the command prompt will open in the exact location of it. So now here type Python space app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser and go to Google Chrome, paste it, click enter. So now you can see the project home screen or welcome screen, the project title fruit quality detection using deep learning for rotten and fresh fruit classification. So just click this login menu, it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the review part where you can upload the fruit images and you can see the prediction result of it. So here you can see the choose file option. After that you can see you can select the model, which model you wanted. We have done two different models, Inception v3 and MobileNet v2 model. So whichever model wanted, the user can able to select it. So let me show you with a few cases of it. So now go into the source code location. Inside that we have the test data folder. So let us see with the each cases one by one. So now let me go to the bad quality and let me select an image. This is the image I selected, and here you can see the selecting the model. I'll show you with the each model one by one. First let me select this Inception v3 and then click submit. For the first time it takes some time, and next time it will be showing the results somewhat quicker than the first time. So now it is navigated to the prediction result page. So here you can see the image that I have selected, and here you can see the model that I have selected was mentioned as Inception v3, and the fruit quality result, the predicted result is apple bad. So you can see another option that we have provided an enhancement that you can download this result as a PDF format. So just click this download PDF. So now let me save this as a prediction result 1 and save it in the desktop. So this result, whatever the result that you get, it will be exported in a PDF format. So this is for the future reference, you can just use it. So now for checking with the other case, I'll just go to the preview menu again. So now I'll just select the choose file option. So this time I'll just go with the other case of banana, and I will select the model as MobileNet v2 this time and then click submit. So now you can see the picture result with the image that I have selected. The model that I have selected was MobileNet V2 and the fruit quality detected was banana bad. So you can just download the result as we did it for the previous case. I'll just save it as 2. So you can just see the exported result in the PDF format. So now I'll just go for the preview menu again. So quickly let me select for the each cases. I'll just select this image. I'll just keep the model as Inception V3 and click submit. So now you can see the printed result with the model selected. So the printed result is Goa bad. So now let me go to the preview part again. I'll just go to choose file. I'll just go for another case of the image and click submit. So now you can see the printed result is lime bad. So now let me go to the preview part again. I just select another case from the other image. This is the image I have selected and let me click submit. So now you can see the image I have selected and the pictured result is orange bad. So let me go for the preview part again. So let me go for the other fruit case and I'll just click submit. So now you can see the image that I have selected and you can see the pictured result is pomegranate bad. So now let me go to the preview part again. Now I'll just go with the other class of image and let us see it. So now let me select this image and click submit. So now you can see it is apple good. So let me go to the preview part again and let me select an case from this image and click submit. So now you can see the pictured result is banana good. Let me go to the preview part again and let me select an image and click submit. And now you can see the printed result is Goa good. And let me go to the preview part again. I just go for the next case. I select an image and click submit. So now you can see the printed result is lime good. Let me go to the preview part again. I just go for this case and click submit. So now you can see the pictured result is orange good. Let me go for the preview part again. Now let me go for the other image and you can see the image that I have selected and click submit. And now you can see the pictured result is pomegranate good. So now let me go for the preview part again. So now let me move to the next category with the mixer and I'll select an image and you can see the image and let me see the pictured result. So you can see the pictured result is apple good. So this is a mixed quality but it shows that apple good. So in this way sometimes the results may also given the wrong result. So let me go to the preview part again. I'll just select some other image and let us check with the other case. So now let us select this image and let me select with the MobileNet model. And now you can see it is giving a wrong result also because it is showing us pomegranate good. So this kind of wrong results also will be shown because any model cannot be 100% accurate. So let me select with the other image and let me click submit. And now you can see it has predicted the correct result as apple mixed. So in this way you can also check with the other cases. So now let me go to the preview part again. I'll just select and go for the banana mixer and let me select this image and click submit. So now you can see it is printed correctly as banana mixer. Let me go for the preview part again and now let me go for the other fruit. So let me click submit. So now you can see it is printed wrongly as apple good. So now let me select this image and Inception V3 and click submit. So now you can see it is predicting as lemon mixed. So now let me select this image and then let me select the model as MobileNet V2 and click submit. So now you can see it is predicting correctly as orange mixed for the MobileNet model. So in this way you can select whichever the images that it is showing correctly, so that you can show those things in their review or the guide panel. So now let me move to the preview part again to check with the other case. case of this final case with the pomegranate. So let me select this image. This is the image that I selected and click submit, and now you can see it is printed correctly as pomegranate mixed. So now finally you can also, I'll show you, you can also select the images that is available in the training part. So in the training part we have lots of images. So let me select some image randomly. Here I'll select this pomegranate image and click submit. So you can see it is printed correctly as the pomegranate. So now here the question is, what happens if I'm going to give some other image that is not a fruit image? For example, if I'm giving a bus image or car image something, so the system is not trained with it. So the system knows only the classes of the fruit names that we have printed. So it shows some random result only. So you need to give only the fruit images that is trained according to the data set. So in case if you are giving other images from the other than the data set, so it must be in the same format so that it will be predicting correctly, or else it will not give the results correctly. So for example, I'll just go to the Google. So I'll just give rotten guava. So these are all the images that we got for the rotten guava. So let me select some image and let me select this image. Let me save this image. Test1. I'll just save it as a test1. Let us check whether it is working or not. So in the desktop I have just used this test1. So this is the image I have selected. So now let me select mobile app model and let us predict it, but it is predicted as apple good. So now let us test with this image. Test2. Go for the preview part. You select this image and click mobile net and click submit. So now it is printed correctly as the guava bad. So now, because the system earlier image that is given is not perfectly matched with the trained data, so it does not given the correct result. So if you wanted to add more images to make the system accurate, you wanted to train the model again in the backend so that it will be showing with the new images also. So for example, finally I'll show you with the rotten banana. Let us check with this rotten banana image. So now I'll just download this image. Test3. And let us check it. So now you can see it is printed correctly as the banana bad. So this image is not available in our training data set, but it has printed correctly as the banana bad. So in this way you can train the system, and also you can test the system with the images that is equivalent to the data set that we have trained up the model. So in this way you can check with the other images that is provided in the test data and also in the train data, and you can check it out. And now let me move to the next part, that is the performance analysis part. So just click this performance analysis part. So in the performance analysis part, we'll be having the performance analysis for both the model of MobileNet v2 and the Inception v3. So here in the performance analysis, we'll be having the recall, F1 and precision for all the classes of apple bad, apple good, apple mixed, banana bad, banana good, banana mixed, guava bad, guava good, guava mixed, lemon bad, lemon good, orange bad, orange good, orange mixed, pomegranate bad, pomegranate good, pomegranate mixed. And you can see the confusion matrix of the MobileNet model with the true and the printed label of it. Then coming to the performance analysis of the Inception v3, we have the recall, F1 precision for the classes of apple bad, apple good, apple mixed, banana bad, banana good, banana mixed, guava bad, guava good, guava mixed, lemon bad, lemon good, orange bad, orange good, orange mixed, pomegranate bad, pomegranate good, pomegranate mixed. And similarly we'll be having the confusion matrix of the Inception v3 model with the true and printed label of it. So this is the performance analysis part. And finally we'll be showing the chart part. This is the static visualization chart which contains the model accuracy chart, class distribution chart, inception v3 accuracy chart, inception v3 model loss chart, mobile net v2 accuracy chart, mobile net v2 model loss chart. So here in the model accuracy chart we'll be showing the comparison of the inception v3 and mobile net v2. So here inception v3 with the train accuracy of 94% and test accuracy of 94%, mobile net v2 with the train accuracy of 97% and test accuracy of 98%. And then coming to the class distribution chart, so you can see the class distribution of the various classes. So here pomegranate good with 30.4%, pomegranate mixed with 0.6%, apple bad with 5.8%, apple good with 5.9%, apple mixed with 0.6%, banana bad with 5.6%, banana good with 5.7%, banana mixed is 1.5%, guava bad with 5.8%, guava good with 5.9%, guava mixed with 0.8%, lemon mixed with 1.4%, lemon bad with 5.6%, lemon good with 5.6%, orange bad with 5.9%, orange good with 6.2%, orange mixed with 0.6%, pomegranate bad with 6.1%. And here you can see the inception v3 accuracy chart, inception v3 model loss chart, and then mobile net v2 accuracy chart and the mobile net v2 model loss chart. These graphs, these plots plotted from the model graph. And now let me log out. Before completing, let us see about the frequently asked question for this project. So the first question is, what is the main purpose of this project? So the main primary goal of this project is to automatically classify the fruits into 3 different categories: good quality, bad quality and the mixed quality, using the deep learning, so that it will be helpful for the farmers or vendors or quality control teams for identifying the fruit quality efficiently and accurately. Next question, which fruits are supported in this system? So we have selected apple, banana, guava, lime, orange and pomegranate for this system. Next question, what deep learning models are used in this project? So in this project we have used inception v3 and mobile net v2 architecture. Next question, what is the size and structure of the dataset used? So the dataset contains 19,526 images, which is divided into good quality fruit images, bad quality fruits and mixed quality. Next question, how is the system deployed for use? So the system is deployed as a web application using Flask web framework. So the front end is built using HTML, CSS and JavaScript, so that the user can able to upload the images and check the prediction result. Next question, what pre-processing steps are performed on the dataset? So we have used the pre-processing steps like data collection, labeling, pandas data frame creation, label type conversion to categorical format, sample image dimension analysis for resolution understanding. Next question, what performance evaluation metrics are used? So we have used accuracy, precision, recall, F1 and the confusion matrix. Next question, what makes this image, so the system better than the existing system? So in the existing system, the traditional system, they have used binary classification, but here we have enhanced the system with the 3 quality, and also we have used larger data set, structured data set, to achieve higher accuracy with the higher data set. And also we have implemented with the real-time scenario, so that it is implemented practically. Next question, can this system be expanded into more fruits? Yes, the system can be expanded with the more fruits, but the system, the model should be retrained again in the backend model. Next question, how fast is the prediction process? The prediction or process within 2 to 3 seconds per image, depending upon the model selected and the image sizes. Next question, is the image uploaded stored anywhere? No, we have not used any database, so it is not going to store the images anywhere. Next question, who can be benefited by using this system? So the main beneficiaries like farmers for quality based sorting before selling, vendors or retailers so that they can check the fruit quality before purchase or packaging, agro industries for integrating into automated sorting lines, researchers and students for studying AI applications in the agriculture. So these are all the people who can get benefited of this system. And these are the frequently asked questions for this project. And this is all about the project fruit quality detection using deep learning for rotten and fresh fruit classification. And thank you for watching.